1 second.
Okay, we are now starting our 4 p.m. meeting. Third time is the charm. 4:16. And begin with the roll call and have the general manager then read preliminary information.
Directors Sethy,
Here.
Akbari,
Here.
Gunther,
Here.
Huang, here, and Weed.
Here. We're on a Zoom meeting, so if there's a preliminary comments that should be made.
Sure, some quick housekeeping remarks. Good afternoon, everyone. My name is Ed Stevenson. I'm the general manager of ACWD. I'd like to welcome the public's participation and the participation of quite a number of staff and our consultants here. Members of the public may participate in this board meeting in person or remotely by either using the Zoom application or by telephone. Any member of the public participating in person may approach the speaker's podium at the appropriate time. For those participating remotely, note that the meeting agenda, staff reports, and presentation materials are all available on the district's website at acwd.org. You may reference the instructions at the top of the agenda for how to participate using the controls in the Zoom app or your dial pad if you're participating by telephone audio. This hybrid board meeting is being recorded and will be made available to the public for future viewing. Again, thank you all for attending, and that completes my housekeeping remarks.
Thank you. Please join us for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic that stands one nation, under God, indivisible, liberty and justice for all. At this time, we have public comments on matters on the notice of the special meeting. Is there anyone who wishes to address the board on an item that is on this agenda? Is there anyone online that is indicated an interest in addressing the board? Apparently
I'm not seeing raised hands, and there will be opportunities as we go along for questions and comments from the public and of course from the board.
All right, thank you. The fourth item is the workshop to review the Weber District's plans for PFAS treatment.
That's right. Thank you, President Weed. And I'll just kick things off real briefly before I turn it over to our directors of engineering and technology and operations and maintenance, who will further introduce our workshop today by just indicating that I think we all know PFAS is a large and complex topic. The board's been very engaged in this, and this has been something that staff have been obviously very, very engaged in for some time now. And there's been a lot of developments in this area since we last spoke with the board last January. Primarily developments in the regulatory arena. So there's a lot that we want to present. We will do our best to step through items that we believe the public and the board are somewhat familiar with, but we're obviously very willing and interested to provide all of the information and context that's needed about any of the things that we talk about. So we'll be covering a lot, but spoiler alert. And I just wanted to raise this at the outset so we don't lose track of it as we go along, because there is a lot of information here. Spoiler alert, in terms of what staff is proposing that we do with regard to PFAS, it's very much the same as January. In January, we were proposing and discussing a 6 million gallon per day treatment facility at the blending facility. We're still proposing 6 million gallons per day of PFAS treatment. The primary difference, and there'll be a lot of information that explains why and the ins and outs, but the primary difference is that we're proposing that we build it so that it could be scaled to a larger capacity if we need it to, right? To deal with these emerging regulations, some of the uncertainty that everybody understands and acknowledges exists out there. So that we build a 6 MGD facility, but it's scalable to 15 MGD. And that's where we are right now. And so I just wanted to make sure that doesn't get lost in all of this.
Could I ask a question related to that? Will it also have, we also considered the ability to transfer or change the method of technology to go to reverse osmosis if it's determined that that's the
You bet we have.
technical means?
Yeah, and
Thank you.
we'll talk some more about that in the presentation. And again, whatever topics the board would like to really focus on, that's why we're here. So yes, that'll be part of what we talk about. And so that approach, 6 MGD, but scalable to a larger capacity, in our view, still meets the overall objectives that we have for this project, right? That's ensuring that we're treating this water that we serve to our customers to levels that are below public health concern, that we're minimizing the life cycle costs. We're not building something that is going to be a stranded asset. And so, so that's the key sort of foundation that I want everybody to keep in mind. And with that, I'll turn it over
Can I
next.
ask one more question?
Of course.
In your presentation, we'll be looking at also how we will address the waste stream.
Yes, we'll talk about the waste streams. Yes. And again, we can go into further detail as needed.
Okay.
So yeah, there'll be plenty of opportunity as we start presenting content. And I would say to that also that should the board or the public have issues or questions that are burning at the time we're presenting some material, don't hesitate. We will be pausing after certain segments within the presentation, but we also want to ensure that you guys get the information and the answers that you need. So with that, I will kick it over now to our Director of Engineering and Technology, Mr. Groom Arope.
Thank you, Mr. Stevenson. I appreciate the opportunity to present this workshop today. Good evening, board members, community members, and staff. As Mr. Stevenson alluded to, PFAS is one of the most prominent and evolving issues that many water districts are facing nationwide, as you all know. The board has previously directed staff to study and identify possible treatment methodologies for PFAS compounds in the district's groundwater sources. In today's workshop, we plan to present to the board an overview of PFAS compounds, operational considerations, and treatment approaches that will help the district meet its strategic objectives. The presentation is organized in 4 distinct parts. The first part will be focusing on PFAS compounds and the regulatory environment in general. The second part will cover the impact of PFAS in the district's water quality and production goals and considerations. The third part of the presentation will focus on treatment selection processes. And finally, we'll tell you about the specific capital improvement project that staff is working on. We will have, as Mr. Stevenson mentioned, we'll have a time for Q&A at the end, but definitely we will pause between transitions to make sure there is opportunity for questions and discussions on topics. I also want to point out that we have reference slides in your packet that we might refer to just to elaborate on some issues or items. I want to say that this is truly a multi-department effort that requires continuous collaboration and effort among the team members. And to that end, I want to introduce our speakers today, starting with Ms. Carrie Smith, who's a project manager in the project engineering division. Mr. Ranga Sampath is environmental engineer in the water production division. Mr. Mike Wickham is a water production manager in operations and maintenance. Dr. Brian Pexon is with Trussell Technologies. They're the consultant helping us with this project. Also is Miss Emily Darby with Trussell Technologies. We also have in the room Miss Rekha Ipagunta, who's project engineering manager, and Mr. Ben Egger, who is project engineering supervisor, and Miss Chris Pena sitting all the way in the back, our engineering supervisor in water production, to help answer some questions and provide additional information. If you'll allow me with that, I'll turn it over to our Director of Operations and Maintenance, Mr. Arentz, to speak on the specific workshop objectives. Thank you.
Thank you, Mr. Woke, and members of the board, President Weed, and members of the public. Just real quick, I want to review hopefully what we have hoped to achieve tonight and some of the objectives of this presentation and the workshop. First, we want to develop an understanding of how PFAS currently affects our operations at ACWD. Then we want to really key to this discussion is based on potential regulations, how PFAS may affect us in the future, which is what we're trying to anticipate and plan for. We want to share various health-based standards and what it means to exceed those standards and what the risks are going forward. We can kind of understand both sides of the equation. What staff's approach is in trying to minimize these risks. And finally, lay out a path forward and the next steps for the project. So that's what we hope to achieve. And with that, I'd like to introduce Ranga Sampath, environmental engineer in our water production division, who will start us off with an overview of PFAS. Mr. Sampath.
Thank you, Mr. Aarons. Good afternoon, members of the board, members of the public, district staff, consultants. My name is Ranga Sampath. I am an environmental engineer in the water production division here at the district. Been involved on this project for quite some time. But this evening, I'm going to talk about what are PFAS? Why are they such a big deal? We've been hearing a lot in the media, a lot of health concerns, a lot of studies. These are a class of over thousands of compounds that have excellent physical and chemical properties, which have been used in almost everything that we use in our daily lives. But they're pretty persistent and are widely prevalent. And there have been numerous studies done about their health risks, and particularly now the focus is presence of PFAS in water. So with that, in my overview, I'll be talking about what are PFAS and why we remove them. I'll talk about water quality goals and the district's mission statement and our alignment of water quality goals where we meet or exceed all the regulatory criteria. So we've been doing that as part of a mission statement, and that is our core mission here. And more so for me in water production, it's very near and dear to my heart. Description of levels of concern. PFAS do not have any MCLs yet, but it's an evolving process. So I'm going to talk about a couple of levels of concern. And these are what the Division of Drinking Water calls the notification levels and the response levels. I'll also go over the district's monitoring program, which we have had for over 2 years now. And we have had all the data presented on our website. So all our customers can look at the data and what we have been doing. And there is a lot of information on our website on PFAS FAQ and what they are. And finally, I'll finish off my section with operational strategy, what we have implemented for PFAS control, primarily with the goal of remaining below the notification levels for PFAS constituents that have those numbers set up so that we are not exceeding those levels. Per and polyfluoroalkyl substances, collectively, that's what PFAS. There are thousands of them. Have presented this a couple of times, and we know what they are. A family of synthetic chemicals, man-made, several thousands of them. Very good properties in terms of resisting heat, oils, and water. But the issue with that properties is they're very prevalent and persistent in the environment. They don't biodegrade, they don't break down. So they are, if you look in the media, they're called forever chemicals. Like I said, they're used in the manufacturing of anything from stain-resistant carpets, non-stick cookware, fast food packaging, firefighting foam, personal care products. So across the entire spectrum, we have these chemicals. Why remove PFAS? So there's a lot of ongoing research on health effects for these, both in animal studies and the of these PFAS compounds. 4 are of concern now because those 3 of them have notification levels, and one is the Division of Drinking Water is coming up with notification levels very soon, PFHXS. But why these 4, PFOA, PFOS, PFBS, and PFHXS? These are all long names, which we won't go into, but for our discussion purposes, there have been numerous studies. These 4 have been widely found in blood serum samples in humans across the United States. There have been numerous studies done just to give a glimpse of what are all the health effects, anything ranging from reproductive effects, increased risk of some cancers, reduced immune system and vaccine responses, increased cholesterol levels because PFAS, they tend to have a pretty detrimental effect on liver. And recently there was in fact a study done where PFAS concentrations in the parts per billion range were proven to be 5 times as toxic to the liver than previously thought. So there's a lot of health effects and numerous medical studies that are being done. Also consistent with our water quality goals, where we meet or exceed all standards, even though there are no MCLs, the district has taken a very proactive step to keep the concentrations of substances that have notification levels below the notification level in what's being served to the customers. And I'll briefly touch upon regulatory trends, because for these 4 PFAS compounds, there is regulation coming, and Mr. Vikram will talk about the what's in the future with regards to the regulatory trends. But there's a lot of science and data that's out there in terms of establishing what we call notification levels and response levels. The district's mission is to provide a reliable source of high quality drinking water at a reasonable price to our customers. And that includes providing water with contaminant levels below levels which may pose a significant health risk. So it's not only MCL, but anything that has a potential health risk, we prefer not to exceed those. Our district strategic goal that was laid out, 1.2, is to continue to meet water quality standards 100% of the time. And we meet and surpass all primary and secondary water quality standards. Now, the primary standards are health-based, MCLs in this case. The secondary standards are aesthetic and include odor, taste, total dissolved solids, etc. And we meet all regulatory treatment requirements for treatment and distribution of water at all times. And the blending facility, which is the focus here of our discussion this evening, mostly, is we meet the hardness target of 150 ppm because it's groundwater blended with purchased San Francisco water. So as you can see, we have been carrying forward this mission statement all along with the quality of water we have delivered to our customers. So few terminology for this evening, because like I said, PFAS do not have MCLs yet, but in a couple of years, those will be coming. So there is a sequential process in establishing these MCLs. So 2 things to remember, 2 terms this evening is notification levels, which is essentially the level of a contaminant in drinking water that does not pose a significant health risk, because these health risks, like I mentioned a couple of slides back, there's multiple lines of evidence that these are toxic at very low levels too. These are health-based advisory levels established by the Division of Drinking Water for chemicals in drinking water that lack MCLs. And how are these levels established? So the Office of Environmental Health Hazard Assessment, based on peer review of literature, what's out there, based on what is detected amongst human population, based on any studies, and evidence of studies, they establish these levels. And but the thing to note is the risk assessment there considers only health risk and exposure, which is important, but not the cost, because the MCLs also takes into account feasibility study for treatment and cost. So that's the difference. And these are established for contaminants that may be considered for MCL development. And there are certain requirements that utilities have to abide by when these levels are exceeded. And I'll talk about that in the next slide. Response levels are very similar, but there is additional steps beyond notification that needs to be taken to reduce public exposure to the contaminant. And one of those is basically removing the source out of service. So a response level is where the threshold or the level is a little higher, but the reaction of the response is more immediate and something needs to be done. Unless there is a blending strategy or treatment already in place, if a response level is triggered, the source needs to be removed out of service. And of course, we do know MCLs because these are the highest level that's allowed in public drinking water supplies, and they're established to protect primary health. And MCL establishment considers feasibility of treatment and costs. And MCLs, as we know, are enforceable standards. These are also referred to as primary drinking water standards. clicker. Next slide, please. Thank you. So what happens when a notification level is exceeded? The utility, for us, for example, we have to notify the board, the county board of supervisors, and the governing bodies of the cities we serve. And the notice needs to include the contaminant concentrations, the source and its status, what was the notification level, and and a very plainly worded health concerns. So that's complete transparency out there to the public when we exceed a notification level. And in addition to that, it's required that we have to, as per Assembly Bill 756, we are required to include the data in the annual consumer confidence report. And DDW also recommends that the customers and consumers are aware of the presence of the chemical and the health effects associated with that. Exceedance of response level is more serious. The source, unless you have treatment or blending, you need to take the source out of service and be proactive about doing something. And provide public notification within 30 days of the exceedance to take the water source out of use. And the public also needs to be notified within 30 days of the confirmed detection and report exceedance of the response level in the annual consumer confidence report. So these are the two terms, because currently the PFAS chemicals in their evolution toward establishing MCLs, these two are the thresholds that have been set by the Division of Drinking Water for 3 PFAS compounds, which are the most prevalent and have been known to have the most detections. And there is a fourth one, PFHXS, which we will also talk about tonight, because that's the Division of Drinking Water had a discussion yesterday, but Mr. Wickham will talk more about that. But we will also go into the fourth PFAS chemical. Next slide, please. So knowing those levels, what they mean, here are the notification levels and response levels for 4 of the fourth one, PFHXS, like I said, is work in progress. But 3 of those, PFOS, P4, and PFBS, the notification level and response level have been established. There is something you will notice on the table, the PFBS thresholds are fairly high, the notification. The reason for that is PFBS came as a later PFAS compound that is relatively less toxic based on the chemistry versus PFOS and PFOA, where the original PFAS compounds with, not to go into too much chemistry, but stronger bonds and longer chains. So as manufacturers started making less toxic PFAS, but again, it's widely detected. That's why you see a notification level and a response level there. PFHXS, that's the latest one with the notification level of 2 parts per trillion and 20 parts per trillion response level. In terms of the regulatory arena, which we will, like I mentioned, we will go into greater detail in the future slides. The EPA is expected to establish federal MCLs for PFOA and PFOS in 2023. And what we have heard, the Division of Drinking Water is expected to establish state PFAS MCLs in 2025. So this is, as science progresses, more and more studies come into play, treatment technologies, it's an evolution. Eventually, that will culminate in an MCL for all of these. Next slide, please. Parts per trillion, to put it in perspective, I know we have been in the parts per million range, then we moved to the parts per billion range in water. Now we are in the parts per trillion range. So just to, in terms of water, it's essentially a single drop, as you can see there in 20 Olympic-sized swimming pools. Now, it is a very, very, very small amount, agreed. But the toxicity and the studies have demonstrated that even those low concentrations, like I had showed in the previous slides, there are health effects. And that's why based on those studies, we do get these very low numbers. So the takeaway is there are health concerns for these PFAS compounds, the 4 that have been widely detected, even at very low concentrations. Next slide, please. With regards to our monitoring program, which I've covered before, but I'll just breeze through this. We are in 2020, the district embarked on a voluntary monitoring program. So with the whole attention on the PFAS, the Division of Drinking Water had issued monitoring orders for several utilities out there, both drinking water and wastewater treatment plants. But ACWD did not get any monitoring orders, but nevertheless, in light of meeting our customers, our mission statement, and to be sure that the water we serve is of the highest quality, we did a voluntary monitoring program for PFAS in June 2020. We began that and we're continuing that since the time on a quarterly basis. Samples are collected at all source wells, the Maury and the PT well fields, which feed the blender. We also sample the desal supply wells. Purchased SFPUC water. We wanted to know because of our blending facility, we blend groundwater with purchased water. So we want to know what's there in our other sources that we purchase. And also upon blending and various treatment, what's of ultimate goal and importance is what we serve our customers, the distribution system entry points. We also collected samples at our surface water treatment plant, both the raw water and finished water. And every quarter we've been publishing the results on our website, in addition to all the PFAS information that's there for the customer. The good news is, for all these quarters that we have sampled, we have always maintained all detections at entry points, what we're serving the customer, to the below the notification levels. But that was done because there's no treatment yet. That was done by implementing operational strategies. And we'll talk more, Mr. Wickham will talk more about the operational strategies and the blender production capacities in later slides. Next slide, please. So this is a busy table, I know, but the takeaway, as you can see, is the first column, PFAS concentrations detected in both the Maury and the PT well fields. Not very high, but nevertheless, the thing to note is, as we saw, as low as 2 parts per trillion, for example, for PFH excess, or 6.5 parts per trillion for PFOS, we do know that there are health concerns. So we are about twice as much, but not a whole lot. But again, the thresholds being very low, it is of concern. S1, the treated water from blending facilities, something I would like to point out, that that is the entry point of the distribution system from the blending facility. And even our range has never exceeded the 6.5 for PFAS. And the average has been maintained below the 6.5. But again, that was because as soon as we found out that we have some low levels of PFAS in our production wells, primarily the blending facility, we decided to implement an operational strategy. PFHXS, to the extreme right. So that will be coming pretty soon, the notification level. The Division of Drinking Water had an information session yesterday. So those notification levels, we did not hear anything otherwise. So our best guess is those are going to be the notification levels. We haven't heard anything different. Next slide, please. So the operational strategy was done so that we meet our water quality goals. No customers to receive water with PFAS levels exceeding health-based notification level. As I mentioned, our mission statement is to serve water with the best water quality, irrespective of having MCLs or other health-based thresholds. So in this case, notification levels are the health-based thresholds, and we meet that. As part of the operations, what we did was blending facility ratios were such that the PFAS levels were below the notification levels. And as we know, blending facility is groundwater pumped mixed with HHE or SFPUC purchased water. So as a result of the blending operational changes, we had an increased SFPUC use because we couldn't get, we had to put more SF instead of groundwater because of PFAS, but we have a lower hardness, obviously. But what has led to is, that's the most important discussion perhaps this evening, is it has reduced our blending facility production rates, which Mr. Wickham will talk in greater detail, but we have had an offset or a reduction in production, if you will, from the blending facility, which is actually the largest facility we have. Next slide, please. With that, that's my section on the background of PFAS and why we are monitoring and what are the issues. If there are any questions, we could take them, or I will turn it over to Mr. Wickham.
Question, members of the board. Question I have, you had a chart which
Yes.
showed where we have identified PFAS in our system.
Right.
It showed, oh, we can pull up the chart if you could. It showed none and non-detect in the Maury well field. But we did have PFAS in the,
Oh, sorry. Can you go to the slide?
here we are. Yes, here we are. So in the Maury two, non-detect. Maury, the other wells, we found some.
Right.
So we have at least one well where there's non-detect.
Yes, and thank you, Director Weed. Yes, so if you look at the Maori 1, 3, 4, 6, 7, 8, 9, they are all not screened in the deep aquifer. Maori 2 is our only well that's screened in the deep aquifer. The good news here is the PFAS, by whatever mechanism, hasn't yet reached the deep aquifer. That's why Maori 2 has been non-detect.
Be interested to see a graphic map of where these are located and the concentrations we see in our groundwater basin or our well fields. And might there be other locations in our groundwater basin where there'd be non-detect that we look to see if merely relocating our wells to a different location would address the issue immediately in the near term?
Well, can I build on that question?
Please.
At our desal facility, before we put water into the distribution system, we're
Mhm.
mixing it with groundwater. And there we don't have any detection of any of these PFAS.
Except for PFH excess, the blended product water, yes. So the Cedar 2 blend around is the well that's does not go through reverse osmosis, but nevertheless, all the other wells going through the treatment, blending with Cedar 2 water, yeah, the detections are below the notification levels, yes.
And if I
I need to
may,
test my understanding here. The groundwater that we're pulling out from over in Newark, where we remix it with desalinated water, is there PFAS going into the distribution system?
No, the well, so the wells that feed the desal plant do have PFAS. Again, similar concentration ranges, not very different. But all of the wells that feed the desal going through the RO basically are the effluent, if you will, are all no PFAS. And then Cedar 2 water, which is a direct blend around, doesn't go through RO. And then what goes from the desal, the treated water or the blended product water that goes into the distribution does not have PFAS. So in terms of the source wells, if you're asking, do the source wells that feed the desal have PFAS? They do.
I don't understand how it does not end up in the
So we removed it, the feed water
The
into
product
the
water.
RO
RO.
has low detection of PFAS compounds. So through the RO process, these compounds are actually removed. So the finished water that's distributed to the customers has no detectable PFAS. I think that's the right way to
Right.
say it.
Said on that one.
No,
next-
I'm not. I need this drawn out for me.
If I could just
There
jump
must-
in.
I always thought that the desal water was, that pure water was then mixed with groundwater
Yes, sir.
before it was put into the distribution system.
It is, sir. And it's mixed at a ratio of approximately 4 to 5 parts of the water that goes through the reverse osmosis to 1 part of the water, the well water. So that essentially we remain below the notification levels essentially by blending. Because the water that goes through the RO process, all of that PFAS is removed to non-detect. And then we have that roughly 75, 80% now of the flow blended with this other well that's coming in that might have PFAS levels of, somewhere around 5, 6, 7, or 8, about 8 or 9 parts per trillion, I believe. And I don't have the data with me, but that's close. And then that's blended down because of the blending ratio, it's non-detect at the water
Oh,
going into the
okay, I
distribution system. Does
see
that make
now.
sense, sir?
So where are the source wells for our groundwater there?
They are physically
they-
located?
Newark Deep Aquifer?
Oh, those are in the center of it.
So the supply wells to desal are screened in different aquifers. So we have the blender on well, Cedar 2, not to get into too much specifics, but the blender on well is a Newark aquifer well. We do have wells that go through the RO process into the membranes. What we refer to as raw water to the plant comes from our what we call the Centerville Fremont wells, which are relatively speaking screened in the deeper zone. They're not deep wells because we do have a deep aquifer, but these are screened relatively deeper aquifers, and they're spread all over Newark. And as you know, we have the raw water pipeline and the Cedar 2 pipeline coming into the plant.
Thank you both for the clarification.
Welcome.
Next,
I think Ms. Haidos has a comment.
yes.
Yeah, if I could just clarify one thing about the deep aquifer. We have not found it in Maori 2, which is a deep aquifer well, as Mr. Sampath mentioned. We are continuing to look further out because we have found it in the recharge ponds, but we do not have deep aquifer monitoring wells sort of between the recharge ponds and the Maori 2. So we don't know for sure if the extent of whether or not it may exist further away. So that's one of the things we're going to be exploring with more sampling. So we haven't found it in Maori 2 yet. Let's keep our fingers crossed, but we're still going to be exploring further whether or not there might be some in other areas of the deep aquifer.
Oh, good. The ability to find a different source in the interim might save us a lot of money in the short term while we're trying to figure out what this is. Second, do we have any measure of the PFOS in the wastewater and our brine from either the desal or other waters that wastewaters? And will we be measuring that?
So the answer is we have not measured it. Will we be measuring it? I'm not sure, Mr. Wickham.
That monitoring is currently not required in our NPDES permit, and we have not measured for it.
Okay, my fear is that that will become, particularly if PFOS is determined to be a hazardous waste, I think it's predictable that that will be part of our discharge permits. Or refusal of Union Sanitary District to accept our water, our surplus, excess production water.
So we are, yeah, we're aware of that potential, and we are continuing to monitor the NPDES development activities regarding PFOS.
Part of that would have a data on whether we have PFOS in concentrated PFOS, and then conceptually coming up with what we would do to have to treat that. And if having to heat it to 600 degrees Celsius, the energy impact on that would take our energy policy and just throw it out the window.
So, we are actively monitoring the NPDES regulations as they develop, and so far there's been no numbers for PFOS, but we are keeping an eye on that with respect to the same concerns you just mentioned, sir.
Thank you.
Yeah, and just full disclosure, I mean, that's a big topic that is in discussion right now in Washington with regard to how federal government, and at least initially, would be potentially regulating PFOS as a environmental discharge or a waste. And so those are things that are happening right now.
Thank you. The questions from members of the board or comments or staff? There being none, thank you very much for your presentation.
Thank you. I'll turn it over to Mr. Wickham now.
Good evening, or good afternoon, actually. So my portion of the presentation will be a recap of the initial project that we came to the board with in January this year. We'll discuss our production impacts, anticipated regulatory activity coming up, a comparison of the regulatory timeline to the blender capacities, then also go over share some of how other agencies we've outreached to are responding to their PFOS issues. Advances. So initially in January, we did come to the board with a project to help restore the blending facility offset production. And that was to identify an interim PFOS treatment system that would treat up to 6 million gallons a day for PFOS removal, at the blending facility and design and do an analysis for the potential implementation by summer of 2023 to restore capacity if feasible. So the project approach was an accelerated approach to restore production and meet the timeline. And so we did pursue a parallel path. We conducted the water quality analysis portion of the project, of the study, basically in parallel with some of the design components for the long lead time items like the pressure vessels. And to support that project, the board authorized an agreement with Trussell Technologies for the PFAS study at the groundwater facilities. And then next slide. Oh, yeah, next slide. Perfect. So some of the developments since we came in January, again, that 6 MGD was basically to help us operate and maintain below notification levels. And the initial goal was to have it installed before an operation before MCLs were in effect, to essentially buy the district whatever time it needed to make the larger decisions it might need to make. Since January of 2022, there's been a few significant developments. The largest one is that the Division of Drinking Water is proposed, and they heard the informational item just yesterday at their board meeting, and there was no commentary on it. So our assumption is that this will be adopted, a 2 part per trillion notification level for the PFAS compound PFHXS, and the corresponding response level of 20 parts per trillion. That notification level is a bit of a challenge for us. So remember from Mr. Sampath's slide with our monitoring results, our average concentrations of, our average concentration in our groundwater basins due to the blending facility were about twice the notification level for PFOS. There are 3 to 4 times the notification, this new proposed notification level for PFH excess. So that does have an impact on us. And but additionally, it may have some impact on our desalination facility as well due to the levels in our Cedar 2 well, but that's outside of the scope of this project. Also, the EPA released interim health advisories for both PFOA and PFOS of 0.004 parts per trillion and 0.02 parts per trillion respectively. So these levels are significant to us, and they indicate that the future MCLs, federal level MCLs for PFOA and PFOAs, are likely to be close to the current California notification levels. And why we make that connection is that these, though California has traditionally been more stringent or lower levels for many contaminant levels than the federal government. In this case, these interim health advisories are actually lower than the draft public health goals. If you remember from last week, public health goals are like the most protected California levels. These levels proposed by the EPA are lower than the draft public health goals proposed by California, which indicates to us that the following federal MCLs will likely be low as well, or at least lower than we had initially predicted. So some of the activity within, also within the state, they will be reissuing their PFAS monitoring orders. Like Mr. Sampath mentioned, in 2019, the state began issuing monitoring orders for water agencies, some water agencies, to monitor for PFAS compounds using method 537, which detects for 18 PFAS compounds. They'll be reissuing those monitoring orders to agencies requiring use of method 533, which detects for 25 PFAS compounds. And between the two methods, they actually detect for 29. So they'll be reissuing those orders. And we have been in communication with the Division of Drinking Water regarding what's on the regulatory horizon. And they've shared that this year's state and federal set-asides budget includes approximately $50 million. That's dedicated to PFAS testing, research, and MCL development. They've also shared they're exploring a broad spectrum testing method for total PFAS to determine if it can be included in a targeted approach to regulation of PFAS by class rather than specific compound, because as you know, there's thousands of these compounds, and setting individual MCLs, they're acknowledging the individual MCL approach might not work. They also plan to conduct, so what they plan to do is to conduct monitoring for total organic fluorine and PFAS using method 533 and compare those results to see if they can identify specific specific tests or surrogate that can act as surrogates to kind of derive, I guess, the class of PFAS and total PFAS mass by results obtained by 533. That's their current approach. They're also exploring an MCL for PFAS based on treatment technology approach rather than MCLs based on, again, on individual compounds. They anticipate California MCLs in 2025. Also, our sources at Division Water, they believe that the EPA is also on track for their timeline of 2023 as far as final MCLs in the fall. They told us to anticipate draft MCLs from the EPA in the spring, which will probably give us an idea of what those final MCLs will be at the federal level in the spring of 2023. But I mentioned the treatment technology MCL approach that DDW is exploring. They did share that they would consider the best available technologies for PFAS treatment. Currently, they're looking at reverse osmosis, ion exchange, and granular activated carbon as what they would consider their best available technologies or BATs. And they're also planning to look into PFAS degradation. So that's some recent news on the regulatory front. So this slide here is to kind of illustrate our blending facility capacity scenarios. So the blue line, the blue bar, I should say, is our blending facility capacity when just controlling for hardness alone. And we can peak that facility at rates of, between 34 to 36 MGD as needed, without worrying about going over any kind of health-based goal. The green and yellow lines, you'll see we've just banded together the blending facility rate capacity impacts of controlling to maintain PFOS and PFOA below the notification levels. And with no treatment, where we're currently operating with just our operational strategies, that rate is about 22 to 24 MGD. And what you see in the shade, the transparent area, that's the SFPUC usage, right? So that's kind of also shows kind of the ratio of that. So essentially, since our notification levels for since our levels of PFOS are about twice notification levels, we need to do a blend of over 50%, slightly over 50% SFPUC to remain below that. Then the orange bar is how PFH excess will impact us to remain below the notification level. Since our ratios, our levels of PFH excess in the wells feeding the blending facility are approximately 3 to 4 times higher than the notification level. That's going to mean we're going to need about 75% of PFAS-free water to blend with. And currently our only source of that is SFPUC water. That's kind of the explanation of these graphs. So again, with no treatment, when PFH excess, when controlling for that, our blending facility max rate will be limited to approximately 15 million gallons a day. And this does not include the use of Mowry 2, but there are some concerns with Mowry 2, and that is the only well currently no PFAS. If 6 MGD of treatment were installed like was initially proposed in January, that would recover the rate at the blending facility while remaining below PFH excess levels to approximately 22 to 24 MGD. To get the full recovery that we had talked about, that we had looked for in January of up to 34 to 36 MGD would require 15 MGD of PFAS-free water, or PFAS treatment. So then this next slide here, this table, I should say, is kind of to put the blending facilities capacity in perspective to the rest of our facilities, our production facilities, as far as meeting total system demands. So this, using just a 55 million gallon a day summer demand, or so I should say summer production need, which is very similar to what we had in the last 2 summers. So just as far as system operations, if a daily demand is say 50 million gallons a day is what people are consuming, our production needs actually vary they vary up to about 55 million gallons a day. And that's to cycle the system for water quality purposes. So that's what these numbers represent. So on the very left, the left-hand column, you see the typical rate, right? So on a typical summertime, like say a July or August month, when we are getting a 55 million gallons a day of production, We'll typically operate water treatment plant number 2 at approximately 24 million gallon a day capacity. The desalination plant will run it at approximately 7.5 million gallons a day. And then the blending facility rates are listed below. When we're just controlling for hardness and it is really close to with our PFOS and PFOA control, about 24 million gallons a day. Controlling for PFHX, that's going to limit us. That's why there's 3 numbers there at the bottom for the blending facility. So, and then the column to the far right is the redundancy, and that's basically individual facility redundancy, production capacity for individual facility. That's not entire system redundancy. So though we typically operate TP2 at 24 MGD during a hot summer month, the maximum we can operate that plant really for any sustained period of time is about 26 million gallons a day. So that facility has about a 2 million gallon a day redundancy. Similar with desal, right? The desalination facility will normally operate at approximately 7.5 MGD. The maximum rate we can operate it at for sustained period is approximately 10 million gallons a day. So it's got about a 2.5 million gallon per day redundancy. The blending facility, with just hardness control, we had some redundancy. As you can see there, with controlling for PFOS and PFOA, we very little redundancy. And when controlling for PFH excess, we have no redundancy. And the -4 there in parentheses, that's to indicate that if we had a 55 million gallon a day production need and we're operating water treatment plant number 2 at its max sustained rate of 26 and say desal at 10 million gallons a day, and if we could only do 15 at the blending facility, we would have a deficit of 4 million gallons a day for our internal production facilities only. So to meet demands, we would be relying more on SFPUC directly or another water source that was not part of our production facilities. So I know that was a lot. But what this table doesn't show is, this is summer demands. What this doesn't show is the impact year round. So the blending facility rate, if limited or PFHX control being this low, will actually have impacts year round. So even winter demands, like say in April, when we normally, or March, when we normally shut down water treatment plant number 2 for its annual shutdown. We normally run the blender during that time at higher rates than 15 million gallons a day. So there will be impacts to that. That might mean shorter shutdowns, what would likely mean shorter plant shutdowns, which could mean deferred maintenance, which could impact summer reliability. So that's not shown on this chart, but I did want to make the board aware of that this impact to our blending facility really does impact our other facilities as well. Slide. So enhancements, this slide here is really just mostly another way of saying the same thing. The blending facility capacities there with no treatment and controlling just for PFOS is about 22 to 24 million gallons a day. If we had 6 million gallons of PFOS treatment, it would restore the lost redundancy when controlling just for PFOS. But if controlling for PFHXS, it essentially restores us back to the level we're currently operating at. So the 22 to 24 that's a result of our operating strategy to remain below PFOS notification levels. And again, this just kind of shows that with 15 million gallons a day of PFOS treatment, the capacity of the blending facility regarding controlling for PFOS compounds would be restored even further. So I kind of showed all that to put in context, try to put in context the risks associated with only a 6 MGD facility, specifically regarding the PFH excess notification levels. As I showed a couple slides ago, on a high demand summer day, we don't really have much system redundancy when controlling for PFOS and PFOA, but we have really none at the blending facility. So, there is a risk, depending on demands and the status of other production facilities. So when that production redundancy is very important is on weeks like when we have taste and odor issues at water treatment plant number 2. And instead of running that plant at the 24 to 26 MGD we had planned for, we're only able to run it at somewhere between 12 and 16, 17, 18 MGD because of issues on the SBA or whatnot. So I just, this is just kind of to, it's just kind of there will be risks of going above the notification level, or future MCLs in some circumstances potentially. All right, so the regulatory capacities and the timelines. So again, August 2019 is when the notification levels were lowered for PFOS and PFOA. Before our discovery and monitoring for PFOS, we were operating the blending facility up to about 34 to 36 MGD. I guess I'll just go across the top. So then in this August, so actually yesterday, PFHXS notification level of 2 parts per trillion likely to be established. We do not yet know what month that will actually be published. And then in fall 2023, we're expecting the EPA to have final MCLs for PFOS and PFOA. And then in 2025, and when state MCLs are expected. We have PFOA and PFOS up there, but our recent communication with them indicate that they're looking at regulating PFOS by class. So a lot of this is going to be dependent probably on what they discover during their studies, looking for correlations in the analytical methods to be able to test for it by those groups. And then along the bottom, again, in June 2020, we implemented our operational strategy to remain below notification levels for PFOS and PFOA that limited our capacity to about 22 to 24 MGD. When this new notification level is established, to remain below it, our blending facility capacity will be approximately 15 MGD. If 6 MGD of treatment is constructed, then we'll, again, that has the capacities there. It brings us back up to 22 to 24, remaining below the notification level. And potentially in the future, if we expand that treatment, then our capacity of the blender will increase. And then what are other agencies doing? So we did reach out to several agencies, and each agency developed their approach to PFOS kind of dependent, well, wholly dependent, I guess, on their individual situation. So many agencies had PFOS levels that were higher than ours, like above the response level for some of their wells. We are very fortunate, or maybe fortunate, or at least somewhat unique in that our PFOS levels are low. They're below the response level and just a little above the notification levels. And we have the capacity to blend to remain below. So we're kind of different from many agencies. So again, many agencies had higher levels than us, and that pushed them towards treatment. Other agencies like ours had options which let them provide water below the NLs and water delivered to their customers. Several agencies didn't have those options prior to installation of treatment and have started down the path of designing and/or installing PFOS treatment. And they're currently delivering water with PFOS levels above the notification level and below the response levels, essentially out of necessity. Water quality and operational managers have spoken with other agencies. All of them have indicated their treatment goals and their water delivered to their customers is to below detection or below the notification levels. So with that, that's the end of my section, so I'll pause for questions.
Are there any comments by other members of staff on this? And bring it to the board. Are there questions on the part of the board?
Director Gunther and I already had our questions answered a couple of weeks ago.
Yeah. My questions relate to the, first of all, what do we do? What is our current detection limit and where do we see that going?
So the current detection limit we can detect is 2 parts per trillion. The question of where do we see that going? I'm going to look to Ms. Darby from Trussell. Do you have any indication of that going?
Yeah. So with the detection limit is a little bit lower than 2, but the lab reporting limit, the minimum limit that they can reliably detect is 2 parts per trillion. This changed about 5 years or so from a higher limit, so it's possible that the methods will improve to get lower detection limits in the future.
But I haven't seen movement in that too rapidly.
So we have the ability to do a 2 EPT detection at this time?
Yes, sir, we do.
But that's 5,000 times higher than the 0.004 parts per trillion
Yes, sir.
level of concern.
Yes, sir. The proposed, health advisories, yes.
Second, have we evaluated what the cost is to put in additional wells into the deep aquifer like Maui 2?
Not to my knowledge, sir.
Well, I
could-
think Ms. Heidiss might want to add to that.
We do have a project in the CIP a couple years out to put in an additional deep aquifer well. And I don't recall off the top of my head, I think it's $1 million+ in there. And then the next couple of years, we'll be studying that as well.
If I look at our total, we have about a 90 MGD capacity, a max draw of 55 MGD. So if we were to take our contaminated wells out of service entirely, for the better part of the year, we'd have no problem meeting our current water supply without having to go into any treatment of for PFAS. Is that correct?
Think about that question, sir. I don't believe so. That capacity, I believe, includes all of the wells, and I believe that includes a blending facility rate of 48.
Right. But if we used desal, which is what, 10 MGD?
Yes, sir.
You have another 7 to 8 MGD from San Francisco,
Yes, sir.
17. We have at least 25 MGD from water treatment plant number 2.
Yes, that would be, you're correct, sir, but we'd be relying on that rate all year long. During winter months, we do have color issues due to the manganese, sir. And during which limits our rate during winter months to more in the 14 to 18 million gallon a day range without risking discolored water.
And Maui currently produces 1 or 2 MGD for a well.
The wells at Maui, they 3 MGD, sir.
3 MGD well at Maui 2. An additional well into the lower aquifer then strikes me would meet our 55 MGD max capacity without having to trigger this other project with undefined requirements as they're going forward and being developed. So it strikes me we have an opportunity at least to build in a window through the winter months. Come summer, it would be a question of whether we draw down to conservation below the 55 MGD requirements, which it appears that with our current conservation efforts would bring us down well below 55 MGD.
Yes, sir.
So the question then comes, as we look at what our real requirement, is there an workaround without this project to meet our needs, particularly during the current conservation efforts that we have, that we've drawn down our max capacity levels well within a capacity that the contaminated well sites are surplus to our needs.
Sir, go ahead, sorry.
Mike, can you go back but at the chart of production capacities? Just so we're all on the same page. I think the scenario we're looking at.
Yeah.
Right, is even in the best case, in the summer, you can do 24 to 26 at TP2, but in the wintertime, that's reduced. Desal maybe 10. And then if you didn't use blender at all, right, you have basically SFPUC supplies, which is 12 at the Fremont plus another.
Plus another approximately 8.
8.
Yes, sir.
So the only way to meet demand, you'd have your entire system, I think, maxed out.
It would take a huge hit. With our current conservation this last summer, or if we continue our current conservation rate, will we be down in the mid-40s for total demand? Peak demand?
Yeah, I mean, I think right now we're mid-40s. We're bouncing around. And again, we do have to cycle the system. So we typically go up another 5 MGD above what the demand is. So we need that capacity built into the system to cycle the system.
Right, and the other thing you'd be doing is, and we can model whatever you want us to model, but the other thing you'd be doing is maxing out your San Francisco all the time. No matter what, and frankly, going over, like right now, we're supposed to be dialed back. We're not that much because we need to ensure that we're treating for
Yeah.
PFAS.
But
But
San
you would be completely maxing out and probably going over on San Francisco a lot.
The question is, if
And-
we have extra San Francisco that we could buy if need be under ASGs. But, and historically in a drought, particularly in the last drought, San Francisco removed their minimum purchase requirements. So we were
During
able
drought,
to,
right, but we're
we
talking about.
purchased even less. But, when we look at the scale of the project we're looking at, which is quite a bit. The question is, could we potentially scale back the project that you're looking at and still meet our demand requirements? Because we're not at F55 MGD. And we could have the potential of developing additional wells in the lower aquifer, which are, and they're permanent, they're good quality water for while it lasts. And we buy time that way.
Sir, one thing I would consider, if it's very likely that at some point in the near future, there will be MCLs established at levels that are below the levels of PFAS in our basins. So if we do not treat that water in some way, it will essentially be unusable. And then the other thing, and I might need to actually refer to Laura regarding the deep wells. And if we use those more, we may draw PFAS into that well as well, sir. And then we would have no wells with no
There's
PFAS.
some extraordinary challenges, and one of those will be the requirement to treat the brine and waste to not have a hazardous discharge, particularly if they declare PFAS to be a hazardous waste. We have some huge hits coming down the pike.
Sir.
The question is, how do we best structure and time our efforts? And eventually we're going to have to, I believe we'll have to go to RO, which is again, another quantum leap in the cost of the treatment. And we'll have universal treatment of RO, including the possibly at even water treatment plant number 2. So that is just ask that we, as we do our planning,
Yes, sir.
that we take a look at what our real demands are, where our capacity is, and what is the time requirement we need to implement very expensive program that sends us in one direction and builds, and hopefully we build as much flexibility as we can as we go down the pipe.
Yes, sir. And another thing, just for your consideration, sir, our demands are low this year due to conservation. And if the numbers we use to generate or to use the 55 million gallon production need as an estimate were based on what we thought were probably more typical years.
Exactly.
2020 and 2020.
So then that comes again into the timing line of how quickly must we expedite this process? Or do we have a little bit of time to work it out, given our current demands, which are reduced, and our other alternative water supplies? They do not have the PFAS issue.
If I could just add real briefly, you make a great point that we're at reduced demand right now. I think one thing to consider if you were to do a scenario where you shifted away from groundwater and more to our imported sources, is we would then be heavily reliant on the imported sources, and with the ongoing drought, there's really not a lot of certainty that we would for sure have that supply available.
Yeah.
So just.
Well,
to put
San
that in
Francisco's
perspective.
water is expensive, but this will add an extraordinary expense to the water we have now. And it'll be interesting to see what the additional cost per acre foot is going to be with this process and program. And San Francisco has water to sell. And then unfortunately, there's an unfortunate practice of over conservation of San Francisco, because if you don't use it, you're going to lose it. And they're now in the process of systemically replacing the highest quality water we have in California with sewage. So because of this fish and other issues, and part of that is the reason they can do it is because we've conserved the water supply in San Francisco. So really it's the horns of the dilemma. It's a great water supply. We don't use it. we may never be able to restore it and it may never come back. So, thank you.
Yeah, and just to follow up, I mean, I don't want it to sound like we are poo-pooing your idea about using the deep aquifer and trying to sort of maximize other sources. This is something we've talked about, like Laura reports, we do have an item in the CIP to add another deep aquifer well. Obviously, there's a lot of risk to that and to any of the alternative sources, right? There's some risk, there's risk and unknowns to all of this, right? So the risk in relying on a new deep well is that we pull the PFAS in quicker. We don't know if it's 4 inches away from the casing right now or 4 miles away, right? So we're doing additional analysis on that deep aquifer project to be able to try and determine a number of things about the new well. But in our view currently, we're seeing that that additional deep aquifer well as being something that will contribute to additional redundancy and reliability. And if it's successful, and depending on how timing goes with a number of things, and if it turns out from a regulatory standpoint, we have to build RO, well, then that would help us bridge the gap, right? Along with the ability to be flexible and deal with the vessels, different capacity of ion exchange. And we'll get to that. But I just want to let you know, it's not like we disagree, but there are, limitations to every approach.
There are two things we can do. One is get better monitoring of the groundwater basin so we know what the water quality is. Those are cheaper wells, and monitoring well can be put in for less cost than a production well. And the more monitoring wells, the better, may be part of our strategy. And second, potentially expediting one or more deep aquifer wells, being able to pull up a quality water supply. Because who knows where these regulations are going. And with the next regulatory hit and everything we've done to date, dated to meet overnight by regulatory action, and we have we have this huge sunk cost. So I would encourage us to look at the flexibility of having additional water supplies that we know are not PFAS contaminated.
Yet. Yeah.
Just as a process check, where are we in the presentation for tonight?
I think we got a ways to go. We're only on.
We're about halfway, sir.
Yeah,
On section 204.
around halfway.
All right, thank you. All right, thank you.
You're welcome. So with that, I will turn it over to Dr. Pexon and Ms. Darby from Trusted Technologies.
Good afternoon. In this next section, we're going to talk about the water quality evaluation and its impact on the selection of technologies for treating this water to remove PFAS. So on the next slide, we see, okay, thanks. So on this next slide, what we're looking at here is your existing groundwater quality. And so this is part of a table that we put together from a tech memo to review and summarize your water quality data. What this table is focusing on is parameters that could impact the performance of some of your treatment options like GAC, granular activated carbon, and ion exchange. And what we're seeing, what we're seeing in this table is that we're generally finding a lot of these constituents at low levels that we think would not impact the media-based technologies like GAC and IX. So you can imagine other charged species like nitrate and sulfate could also potentially bind to these resins, say, and compete with the PFAS compounds, but we're finding them at low concentrations. I wanted to point out as well that the TOC, this total organic carbon, sort of gratefully it's at a low level as well, lower than the levels that we see in Southern California, which also bodes well for these media-based technologies. So if we go to the next slide, those are the water quality constituents that could impact treatment. Here's some of the data then that Mr. Sampath and Mr. Wickham talked about from your monitoring program. We're focusing now on the PFAS compounds. Remember, you did testing, you looked at 18 different PFAS compounds through that testing. 7 of those compounds showed up above the detection limit, and that's what we're showing here in this table. Just if we recap, which are the ones that already have established levels, these notification levels and response levels. It's 3 of them: PFOA, PFOS, and PFBS. So there's 3 that have them already. There's a 4th, this PFHXS, that has a proposed NL and RL. And what we're highlighting here in the red bars is that 2 of these constituents that have NLs and RLs were detected above the notification level. So it's PFHXS and PFOS are detected above this. And so if you want to continue with this goal of producing a water that's below the notification level, then some form of treatment is going to be required. So what are our options? The next slide is, as Mr. Wickham said before, there's 3 technologies that are identified as best available technologies by the EPA, and that's these 3 here: GAC, IX, and RO. Of these, the first 2, GAC and IX, are ones that are more prone to be impacted by site-specific conditions of your water. RO has been shown to provide really excellent protection kind of regardless of water quality. And so one thing that we can do to understand how well that these technologies would work for your specific water is to do some bench scale testing to confirm that they're actually going to perform well and be good choices for you. And so on the next slide, that bench scale testing, what that actually is this rapid small scale column testing, or RSSCT. So when we think about your full scale operations, you have these pressure vessels that get loaded with media, and you put water over them over a long time period, perhaps a year it might take for the constituent, it gets absorbed and eventually it fills up the whole media bed and then it comes out the backside. And so if you want to compare the performance of these different media at full scale, it would take a long time to do this. So that's not a feasible option for a lot of people who need to make some decisions quickly. And so, but instead we use are these scaled down columns. So just these glass columns that I'm showing in the bottom right. You load them with exactly the same media that you would use at full scale. And then we put your specific water quality, your groundwater, on top of these columns. And what they can do is provide us information in a matter of weeks rather than years regarding the performance of these different media. So in the next slide, I'm going to pass to my colleague, Ms. Darby, to walk through some of the findings of this testing.
Okay, thank you. So here I'm going to show the results from the RSSCT testing. We tested 3 ion exchange resins and 2 GAC media that were all media that performed well at other testing in California and are NSF 61 certified. So I'm going to orient you a little bit to this plot. So this is a breakthrough curve. And so on the left side, the y-axis is the concentration of the PFAS compound. We detected, or we measured all 18 PFAS compounds that are in EPA 537.1. 7 of these were detected in the groundwater, and then all of them were removed to levels below the detection limit by using the GAC or ion exchange resin. And so the concentration that we measured in the effluent from each of the columns is shown on that y-axis. Then on the x-axis is the number of bed volumes that have been treated. A bed volume is the amount of volume of media in the column. So this is typically how you measure the throughput for a column, is how many bed volumes have been treated. These bed volumes on this small scale for RSSCT column are directly transferable to a full scale column. And you can do a conversion of how many days of full scale operation this would be by multiplying by the empty bed contact time. So you can see that equivalent days of full scale operation on the top x-axis. Okay, so I want to highlight here the areas shown in light blue. On the graph, you can see that all of the concentration of all of the PFAS was below the detection limit for a significant period of time. So I'm showing the concentration is plotted at 2 nanogram per liter with these open symbols, and that's because that's the detection limit for the method. And then starting around 100,000 bed volumes, we start seeing detection from resin 1 in green and then resin 2 in purple, and resin 3 in gold. So what I want to emphasize here is that all 3 of these IX resins removed all of the PFAS compounds in the groundwater for a significant period of time. I'm just showing one example here. PFHXA is not one that has a notification level, but it is one of the shorter chain PFAS that breaks through more quickly. Actually, all of the other PFAS compounds that we measured with IX didn't break through for the duration of the testing. So it was removed even better than the one that we're showing here. And the reason why we saw such good removal of these PFAS compounds compared to some other testing we've seen in Southern California is because of the high quality of the groundwater that Dr. Pexon was talking about, with the low concentrations of competing contaminants. We also, I'm just showing the results for the ion exchange, but we saw similar results for GAC, where GAC removed all of the PFAS to non-detectable levels for a good chunk of time. And so what this means for your operations is that either GAC or ion exchange would be effective at removing these PFAS compounds to meet the regulatory limits. And they would do so in a way that would extend your operations. So you wouldn't have to replace your media very frequently because of the long throughput before breakthrough. So using the results from this rapid small scale column testing, we did an alternatives evaluation comparing ion exchange, GAC, and RO. We developed a preliminary design for each of these 3 alternatives, a layout and a cost estimate, and then evaluated these 3 alternatives based on these 6 criteria: cost, operability and safety, aesthetics, future proofing, feasibility for long-term expansion, and timeline. And based on this evaluation, we decided with ACWD that ion exchange was going to be the preferred alternative for this interim treatment system. And that is because ion exchange had the lowest cost per acre foot of the 3 technologies, with a cost of around $200 to $300 per acre foot. In terms of operability and safety, ion exchange is relatively easy to operate and maintain with no continuous waste stream. It's unlike RO, you're not generating a brine. Instead, the PFAS is absorbing to the resin, and after about a year and a half, when your media has become exhausted, the vendor comes out and replaces that media. There's also no regular chemical input for ion exchange. It has a high turndown ratio, so a high ratio of the high flow rate to the low flow rate, which gives flexibility for operations. And it has a minimal flush period when you start up a train after exchanging the media every 1.5 years. In terms of aesthetics, this is really what we're thinking about CEQA permitting here. So ion exchange, this is going to be in a neighborhood environment. So we were thinking about how big of impact will this have for neighbors. Ion exchange has the smallest footprint, and we're choosing vessels that have a low height, so they shouldn't be too big of impact on the neighborhood. And then in terms of noise, it has minimal noise that can be managed by having enclosures around the pumps. In terms of future proofing, so ion exchange through the rapid small scale column testing was shown to remove the broad range of PFAS compounds to non-detect levels. And we're going to be using these multimedia vessels that could be repurposed for a different resin or a different for GAC or a novel media, if that's if the science has improved in the future and that's better for detecting or removing PFAS in the future. So these are flexible vessels that can be reused. In terms of feasibility for goals to put in future RO, the ion exchange system has a small footprint, and so it allows that space for a future RO system for hardness removal. And in terms of timeline, of the 3 alternatives looked at, ion exchange, GAC, and RO, ion exchange has the shortest timeline for implementation. So based on these reasons, the district has decided that an ion exchange system meets these goals best. And on the next slide, I'm going to talk about some of the environmental considerations of this system. So while the ion exchange has shown to be effective at removing PFAS to non-detect levels in the water, we want to think about the environmental considerations of this treatment as well. So one of the things to think about is the disposal of the waste media. So every year and a half or so, then you have to replace the media that has absorbed the PFAS and you replace it with a fresh bed of resin. So to do this, the vendor is going to come out and they will remove that media and replace it with a fresh bed of resin. And then they will take that media away and dispose of it safely. There's a few different disposal options. You can do incineration or landfill. We recommend going with a hazardous waste landfill because of the potential that PFAS will future be categorized as a hazardous waste. This option is going to have the least risk for the district. Okay, so that's the spent media. Then there's also the liquid waste that we have to think about. There really isn't a continuous waste stream for this system. The only time that we're disposing of a liquid waste is when we're first starting up that resin after we put in a new bed. So every year and a half, when we put in that new bed, we will need to flush it. And it's just for a few bed volumes because the vendor will already flush it for about 20 to 40 bed volumes to make sure that any potential contaminants like nitrosamines are removed and to stabilize the chloride and pH. So once we get it to the field, flushing it is really mostly precautionary. And so it's a good enough water quality to discharge to the storm drain, which is what other agencies with PFAS treatment are doing in California. There's also a potential to need to flush to the storm drain if for some reason your blending facility needs to be down for an extended period of time. We want to, on a daily basis, have a couple bed volumes of water still flowing through the ion exchange resins to make sure we don't get biogrowth. And so if the blending facility is down for more than a few days, then we would still run a few bed volumes of water through the IX treatment system and send this to the storm drain. But this would be the same high quality of water that we'd be sending to the blending facility, so it doesn't pose any water quality issues for the storm drain. Okay, so those are the environmental considerations. It really isn't the same problems that we encounter with RO where we have that continuous waste stream. This is more managed with what vendors do of disposal of the spent media. Okay, so I think that is the end of this section, so I'll pause for questions.
Thank you. Any comments from staff? Not from the board. Do any members of the board have a question or comment? Question I have, did you develop a cost matrix for the options on capital and operation costs for the other alternatives?
Yeah, so we developed a class 5 cost estimate for each of the 3 alternatives. So class 5 cost option cost estimate does have an uncertainty range of about -50% to +100%. But based on that estimate, so GAC and IX are both similar cost of about $200 to $300 per acre foot, while RO was about 3 times higher, both in terms of capital cost and operating cost. And so around $600 to $900 per acre foot.
That chart would be helpful, just so we have it for our records.
Yeah, it's here in the presentation a little bit later.
Oh, I'm sorry.
Yeah.
Okay. Next on our media, the non-exchange resin. Are they proprietary resins or are they on the general market?
They are proprietary resins. There are different vendors though that make these. So you will be able to do a competitive bid. There's multiple vendors that make these ion exchange resins that are effective at PFAS removal.
Are the resins interchangeable or are we stuck with a particular manufacturer if we go with the particular resin?
They're interchangeable, yeah. The different resins all require the same vessel requirements.
And for disposal, the manufacturer then assumes responsibility for the
Yes.
disposal of the resin.
They would contract someone to do that disposal, but we would put it in the specifications that the vendor will take on that responsibility to.
That would be
Contract
built
that.
into the basic cost, not a cost add-on.
Sorry, say that again.
So it would be based on the amount, it would be at the point of which we need the resin replaced. They're
Yeah.
taking the risk, the manufacturer takes the risk of the efficiency of the resin and how often it has to be taken and disposed of in a hazardous waste site.
Yes, yeah.
Thank you. Yes,
So, as we're evaluating whether or not to move forward with the ion exchange, with the ion exchange method, how much, like, what should we expect the lifetime or the lifespan of this current operation to be before we would need to move to an RO method, given changing regulatory environments or just different operational challenges that we might face?
So in terms of the lifetime, the vessels, the vessels can last for 30 years. I think there's gonna be lots of options for how to repurpose these vessels that they wouldn't be stranded assets. So with PFHXS notification levels, in order to regain a blending facility capacity up to 48 MGD or 46 MGD, then having a side stream treatment for PFAS would still be necessary. The RO, because RO is more expensive than ion exchange, then you want to size the RO system just to treat what is needed for the hardness goals. And then because more treatment is needed to meet the PFAS goals, then you would still use this side stream ion exchange treatment for that.
thank you, Devin. Is there any member of the public that has a question or comment? I see we have at least two members. We see members of the public, but I do not see any hands raised on the line.
There we
If
go.
not-
Yeah.
Oh, okay, we have two hands. That's been moved over a little bit for me. Kelly A.
Thank you very much. First of all, this presentation, I've only read through part of it, but it's pretty good. At least it shows you what other agencies are doing around the state. And I haven't gotten to the cost part yet, but this cost number that they're throwing out of $200 or $300 an acre foot is a fairly reasonable cost, fairly reasonable, you know. And other people that are doing a part-time treatment operation, where when I say part-time, I mean only seasonally, their costs are much, much higher, like double these numbers. So, you know, I find it, and then I wonder what, if you have that trickle flow to maintain to keep your beds healthy, how much water are you using, or would that be usable water? Maybe was that wasted? It sounded like the water was going down the drain. So maybe during the trickle flow period, the water is being wasted. But the main question for this district is this: are you being driven by the notification level? In only one district, only Fallbrook, and anybody who's been to Fallbrook is a fairly nice place, and they seem to have plenty of money. They look like those people have plenty of money to own lots of horses and do nice things out there. It's down there in Southern California. So Are we like them? Can we, do we have that much money to be operating to the notification level, or do we want to be operating to the response level? Now, other districts are operating response level, and they let these PFAS levels go up sky high, and then they go run around and do these things, these PFAS treatment driven by the exigencies of the state requirements. So that's the main thing for this board is, are you really doing this to hit notification levels? And if you choose not to hit the notification level, maybe you should do it anyway. Even if ACWD doesn't care about the notification level anymore and goes with response levels, maybe you do want to build a little plant like this one, kind of a mid-sized plant, just to get your feet wet and see how it goes and play around with this technology. Not play around, but operate the technology, because it does seem like this technology is going to come one way or another. And even people who think that they don't need this technology, a couple of years later, they turn around and find out that, oh yeah, I need this technology, and it's an emergency now because I think I need it real soon. So that's my comment on this.
All right, thank you. I didn't see your question there, so I think I believe we're planning for the detection levels at this time. Next, is there, that was the only hand that was, second, Mr. Nakamura.
Yeah, thank you, President Weed. Let's see, I have a couple, maybe a question or a confirmation that the proposed ion exchange, it's I assume it's an anion exchange. I believe there was a comment or a note saying that this plant could be repurposed with a different resin selection. So I assume that, well, so the question is, if one were to replace the anion exchange with a cation exchange, for example, hardness removal, is the only cost to doing so the exchange of or the substitution of the ion exchange, and that the remainder of the plant is completely repurposable for hardness removal versus PFAS removal? So I guess that's one question. Another question is, my understanding from this presentation is that there's no attempt being made to regenerate the ion exchange, in that it is use it until it is spent and then remove to a landfill and then replace with brand new ion exchange. Is that because the process of regeneration on site would generate too much hazardous waste, and it's just more convenient to remove the solid ion, spent ion exchange to a hazardous material landfill? And I guess I will maybe chime in about the finances later, because I did skip ahead. I admit I skipped ahead, and I see that we will be talking numbers shortly. So maybe I'll stop here and just leave those two questions for the president.
You could repeat the questions, you understood it.
Okay, so the first question was whether we could replace this anion exchange resin with a cation exchange resin, and would the only cost implication be the resin itself? And so the difference, so the answer is no. Cation exchange resin for hardness removal is regenerated approximately every 10 or so hours because of the high concentration of hardness we're removing. That's at the milligram per liter instead of nanogram per liter. So the resin becomes exhausted in the matter of hours instead of years. And so in order to do that regeneration, there's going to be auxiliary equipment that needs to be added, such as brine tanks, the piping to do that regeneration, flushing, backwashing, etc.
I think if the question is, could it be used with other resins? The answer is yes. We have these ion exchange resins, and we could switch between different suppliers of ion exchange resins. I think when we're thinking about the kind of multi-purpose use of these vessels, GAC is another option that could be swapped out there for removal of PFAS. But really, when we're talking about multi-use vessels, it's really multi-use of media for PFAS removal. That's really the implication. There's some other novel adsorbents out there as well that could also be accommodated with these same vessels as well. But really the focus would be on PFAS removal.
Okay,
So-
so that statement of can be repurposed for different resin selection is really aimed at not using it for a different purpose, but really remaining within the scope of PFAS removal.
Yes, that's correct.
Thank you. There are no other questions. Thank you, and thank you very much for your presentation.
So I'm going to pass this on to Ms. Smith to talk about the preliminary, a preliminary review of the proposed project.
Thank you, Ms. Darby. Good evening. Oh, I advanced. I will talk this evening about our proposed interim PFAS treatment project, including the project objectives, scope, schedule, and budget. Our PFAS treatment and compliance objectives are summarized on this slide. We want to continue to meet the treatment objective of providing our customers with water that has PFAS below notification levels. We want to account for the uncertainty of regulatory requirements and changing requirements by making the project scalable. We want to minimize the life cycle cost, ensuring financial viability whether or not an RO facility is eventually built on site. And we want to minimize the risk of stranded assets. For this reason, we're making a scalable project. We can start with building the minimum needed based on the near-term regulations, accepting some risk with that decision as outlined by Mr. Wickham previously in the presentation. The project also has the ability to accommodate future RO in the site plan, and it could be repurposed, as just discussed. An IX treatment facility will provide a cost-effective solution to the district's PFAS treatment and compliance objectives. We will design a 15 MGD facility, but we will have the flexibility to start with constructing just 6 MGD initially, and we can expand that as needed based on future regulations. This phased approach minimizes the risk of stranded assets, and we can accelerate construction of the 6 MGD facility, expanding as needed. This phased approach will also help us with near-term compliance of the PFAS regulations while working on a potential future RO facility, which would take significantly longer to implement. The treatment system schematic is shown on this slide. The project would treat water from both the PT and Maori well fields. Any water produced by the wells in excess of what needs to be treated for PFAS to meet production goals of the blending facility can bypass treatment. Water to be treated will first pass through feed pumps with variable frequency drives. These will control for the flow as well as boost the pressure as needed to overcome the head loss through the treatment system. Next, the water will pass through cartridge filters for particulate removal. The ion exchange media cannot be backwashed, so this is why we need to remove the particulate matter before the water enters the ion exchange vessels. Next, the water will go through the ion exchange vessels. The number of trains varies with the capacity of the system. 7 trains would be needed for 15 MGD, 3 would be needed for 6 MGD. Each train will have 2 vessels in a lead leg configuration. Finally, the water will then go through booster pumps to be boosted back up to distribution system pressure as needed, or it will recombine with any bypass water and enter the blending facility. Just a note here as well, in addition to the number of trains, all of the other elements would have to be scaled depending on the size of the project, the number of pumps, the number of cartridge filters, etc. In addition to what's shown in the schematic, the project scope includes installation of concrete pads, site piping and improvements, SCADA upgrade, instrumentation and controls, and electrical improvements. Here we show the preliminary layout of the proposed project. There is room for the proposed project on the existing blending facility property. We have outlined in green here the footprint of a 15 MGD facility. See, it fits, with our existing blending facility is shown there to the right. And there is still room, even with the 15 MG facility, for an RO facility on site, now outlined here in green to the left. This slide shows preliminary cost estimates for the 6 and 15 MGD facilities. For a 6 MGD facility, we would expect the capital cost to come in around $17 million, and for a 15 MGD facility, around $37 million. In annual operations and maintenance costs for a 6 MGD facility, we would expect that to fall between $870,000 and $970,000. And for the 15 MGD facility, between $2 and $2.2 million. These costs vary based on from which vendor we purchase the ion exchange media. I'd like to note that district labor is included in these cost estimates, and that they are estimates. The expected accuracy ranges are shown there on the bottom of the slide. The project team also looked at the energy needs for the proposed project. A 6 MGD system would have an annual average energy demand of 120 horsepower, which would have a cost of about $120,000. A 15 MGD system would have an annual average energy demand of 290 horsepower, which would cost about $310,000. The team used the PG&E published greenhouse gas conversion factor to look at the greenhouse gas impact of the project. A 6 MGD facility would be expected to generate approximately 185 tons of CO2 equivalent, and a 15 MGD facility approximately 478 tons. On this slide, we show our preliminary project schedule. The team is working on design and permitting and expects to wrap that up in the beginning of 2023. After that, we can move into the bidding phase, and then we could start construction in the summer of 2023. We would expect to finish construction of the 6 MGD facility in December 2024 if we do not pre-purchase any of the equipment. Some of the equipment does have significant lead times. The project team could have the option of pre-purchasing some of these long lead time items. This would save approximately 5 months of construction time. The items that the project team would consider for pre-purchase include the pressure vessels, transformer, switchboard, and the pumps with VFDs. The project team did look at reverse osmosis in the alternatives analysis. However, it was not selected for the interim project. The permitting, design, and construction complexities of an RO facility may prohibit the district from meeting the regulatory timeline for PFAS if this were the selected technology. This is largely because of the concentrate stream. This would require a permitting and construction of a new waste line for disposal. Discharging the concentrate into the groundwater basin would involve significant permitting risk, and it is not consistent with the ACWD groundwater protection program. In addition, RO is significantly more expensive than ion exchange, about 3 times more expensive. The proposed project would be compatible with a future RO plant, however. It could potentially be repurposed to treat a bypass stream for PFAS, or potentially to treat the RO concentrate discharge stream. Moving forward with the project, the team is working on preliminary design and DDW permitting and the CEQA initial study. The team is looking into potential procurement of the long lead times items. We will also be conducting public outreach, both during the CEQA process and before construction. And then we can move forward with final design and construction. Upcoming board actions include an amendment to the engineering services PSA for the scalable facility discussed in this presentation, adoption of CEQA, potentially approving the procurement of the long lead time items, and approval of the construction contract. So that concludes tonight's presentation. Thank you all for your attention. We went through what are PFAS and regulatory issues around PFAS, the district's water quality and operations, our alternatives evaluation, and our proposed project. If we would now like to open it up if there is any additional
Any
questions or
comments
discussion.
Questions by staff? If not, let me ask the board and then we'll take it to the public. But Director Sethy, you
I've got two quick comments. Can you go back to slide 43 and 44? Let's see, one earlier slide. And let's go one. Okay, it's slide 40. Slide 41. So I would just ask that as we take a look at the energy costs on a system like this, and we're not even forecasting the rate increases by PG&E in here, that this may be a really good opportunity to take a look at the Bloom fuel cells, because we have the footprint there. And it might be just a good opportunity to see if it would make sense. I doubt that solar would on that site, but Bloom has a whole new commercial program that just went into effect this last year.
Yeah, we are engaged with Bloom, in fact, sorting out changes in their offerings and so forth. So we're actually talking to them right now.
Great.
Not necessarily related to trying to power this specific facility or anything like that. But we're just trying to get re-smart about other options.
Well, it just opened up a new manufacturing facility here in Fremont where the governor was present with a lot of other distinguished people from state government. So that's one comment. Could we go to the next slide? Next one. There was something here. Oh, right here. How many of these components are coming from overseas suppliers, if any? What's domestically produced?
Yeah, so the vessels can be produced in the US. I'm not sure where the other components are coming from.
But the vessels are a US manufacturer plus the resins?
So some of the resin vendors are in the US and others are not.
Mm-hmm. And have you factored in the backup supplies that we would need just on a contingency basis? Factored in the cost of that?
So for the resins, so there's two factors here. One is they are changed out only every year and a half, and there's monitoring ports throughout the vessels. So you'll get some heads up of when you're going to need to replace the resin. And that does provide sufficient time for contacting the vendor and getting some more shipment of resin. Right now, the lead time for resin is not long, on the order of a few months. And that's for a new contract.
The reason I'm asking the question is that you said it's about an 18-month cycle, replacement cycle. So I'm thinking it would make some sense just to have one cycle replacement in stock. You know.
I don't think you need it because I think they're building it in as a lead lag, right? So if you have a breakthrough in the lead vessel, you still have the lag vessel, the second vessel. So it's two tandem in series, actually. So you have a breakthrough in first one, the second one we still do treatment. So
Yeah, but if the lead time is 8 to 10 months and you
that's
have to
how long-
replace every,
that's how long the resin lasts. That
Yeah.
doesn't mean that's how long you'll take for the resin to get to us. So we could actually get a replacement resin at fairly
but
rapid
it
rate.
seems like if it's every 18 months, you would have to keep an annual order in place.
This slide is for the vessels themselves that you'll only get once. The media could get replaced every, you only need 1 to 2 months of lead time to get the media replaced.
Oh, I see what you're
Yeah.
saying. Okay.
And since we have this lead and lag and we're monitoring it all the time, you'll have a good indication of when you're going to need to replace it. And that time to, just get the new media is much shorter than kind of the window of time that you have to, see, all right, we see the train coming,
Well,
we
that's
can-
why I was asking
Yeah.
whether it's a domestic or international outfit that's supplying the media, because I'm trying to look at where the vulnerabilities might be.
Yeah, it's a good question. I think a lot of the existing facilities that are using these media-based solutions are not storing it, are not purchasing it. Like it remains available sufficiently for them to just kind of get a new order when as needed.
Great. Nice to hear
All
that.
right, thank you. Other questions from the board?
I actually have a question regarding cost. I think there's some references about the IX, we're talking about $200 per acre feet. Is that the all-in deliver finished water cost, or is that just treatment cost?
So $200 to $300 acre foot, that would be the additional cost of IX treatment.
Okay, on top.
On top of the
Okay.
existing blending facility operation.
So question for staff, how much are we paying for San Francisco water that we're using to blend? Because essentially the effluent from the IX is the clean water we're going to use to blend.
Yeah, San Francisco water's $2,100 an acre foot.
Okay, so this is a pretty good deal in comparison.
Yeah, and
Okay.
obviously this would be district owned, managed, operated, whereas we have limited control over future SFPUC rate increases.
Yeah, there's the local supply and supply reliability component, right? That's the intangible, because San Francisco water, no matter how you cut it, is the imported water. Thank you.
Thank you. Other comments? I don't see any member of the board or the community with their hands up. So the points I would make, thank you for the study and presentation.
Director Reed,
Hold on.
I guess
sorry,
maybe I
Jeff.
should comment now. I've been kind of holding back.
Please.
Till sort of near the end, because I'm really troubled by this whole thing. We are chasing a notification limit for a substance seems to be everywhere. That doesn't seem to be going away. Notification limit not pose significant health risks. However, you've also got the response limit or level, which is probably what we're really chasing. And then the MCLs, and I wish I had better faith in the future where these are coming from. This is why I appreciate all the work the staff has done, because we're probably, and this is where I'm really having difficulty getting around this, is because I don't think I have a choice but to accept it. We're heading this way. And nobody's looking at, I mean, yeah, we got some cost on how much carbon it's going to take, their energy, but it doesn't include the disposal costs, future constant, what happens when this goes into the landfill? It stays there. It doesn't go away. We got to build more rosin. We got to get to more rosin and more rosin. Of course, at some point, we're probably not going to be able to use rosin anymore, because we're going to have to go to RO. Because somebody's going to say, oh, now we got microplastics, we've got pharmaceuticals, and water is an easy target. I hate it when we use the word contaminated wells. They're not contaminated. They're showing up with a detectable amount. They're not a contaminated well. We don't have a contamination problem. We have a detection problem. Are we heading towards that? probably are. Because like I said earlier, I don't have faith. They can measure this stuff. They are going to make this bad. I can almost guarantee it. Because then they can say, look, we did something. They don't take into effect the fact that you're going to be first, it's just us. So it's not a big deal, right? We're not going to produce that. They'll take us, take Zone 7, take Southern California. This is going to grow. We're going to have all this rosin production. Where are we going to put it? Nobody wants to build these hazardous waste landfills. So we're doing this to chase detection levels, notification levels. Is this the right thing to do? And part of me says, yeah, because go back to what Mr. Abrams said earlier. If we don't do this, we might put ourselves in more jeopardy when somebody else comes along later on and says, oh yeah, by the way, now your MCL is 100 times less. I'm not going to get in the way of moving forward with this, but I think we have to ask ourselves, and the state has to ask themselves, and the feds have to ask themselves, is this worth doing? Is it worth filling up our landfills with used rosin to get to a detection level? Personally, I don't think so. Problem I know is what I think personally, and what really is probably going to happen. I've seen it in this stuff that goes on. This is not my first look at something like this. I've seen the air board. We don't care what the manufacturer could do. This is what we're going to do. It's the level we're going to set, and they will meet it. Nobody cares about the ramifications. Everybody out there is saying, oh, global warming, global warming, global warming. And yet here we are building a plant that's going to have to run all the time. Once again, to go back to the notification level. So from that aspect, I don't support it. From the fact that we're probably going to have to build it anyway, yeah, I'd be behind it. A great study. And without these studies, we don't have these answers. So all the effort is wonderful. Do I support building this to go to a notification level? No, I don't. Sorry, I don't. But that's not the problem. Problem is notification level is going to become an MCL. And I see that coming way too easily. So that's what I had to say. Great project, great studies. No, I don't support going to notification levels, but I also don't think we have a choice. So I've said what I have to say. I've seen this in committee.
I have one other comment. Director Gunther and I were pretty much in agreement philosophically about what's going on in our committee meeting. And I see this as overkill. I really do personally. But I don't believe we have any choices. And so after thinking about this for quite some period of time, this is how I'm evaluating what we're doing. This is maybe a $17 to $20 million project with a lifespan of 30 years. And so I'm saying, what's the amortized cost over 30 years? And then pulling that back forward. And I think if you do a proper return on investment analysis and look at what the amortized cost is per year, it's a reasonable investment to make on behalf of our community. That's how I look at it.
If I may,
Thank you.
I actually have a request for staff. So the question is, are we intending to apply for grant under the bipartisan infrastructure law? If we are, I think it may have a Buy America, Build America requirement, which means that
We should consider the sources where we source our material.
Yeah.
Because quite a few federal grants does have the Buy America requirement. So just make sure you double check if that's where we want to go, make sure that we don't accidentally invalidate ourselves when we decide to pre-purchase.
Yeah, it's a great point. We are looking at a number of different grant programs. We're even looking at drought relief and resiliency grants that assist, because there is a drought angle here for us. Be able to use that water resources that we don't have full access to now. But that's a really good point. We have been stung by that in the past, so yes, we will definitely do that.
Because there's about $1 billion in bipartisan infrastructure law grant.
Right. Yeah.
Thank you. Director Akbari.
Yeah, I'll just add in my comments. First of all, thank you to staff for a great presentation. Director Gunther and I also had a chance to share some of our comments in the engineering and IT committee meeting last week. And so we talked quite a bit about the difficulties in chasing these changing regulations. I think one thing that I just always keep coming back to that hasn't been mentioned yet for the public is that we're expecting water purveyors across the state and across the country to be as responsive as we possibly can and make these wise investments for the health and safety of our customers. But the people who created this problem, who profited off of these, off of creating these chemicals and releasing them into our environment, just are not being held to account. And for our customers, we're obviously trying to make the best decision that we can, given what we know, what we can detect today, and what we can do to be responsive to both regulations and to the health concerns that we see in our community. But it's just disappointing that our customers are going to have to pay for something that was not their fault. They're having to make these very, very steep investments over decades to be responsive to an issue that was created in the 40s and 50s that other people to this day continue to profit off of. And I think that's something that I'm certainly disappointed by. And I'm hoping that at the state or federal level, there's some assistance given to water purveyors who are making these, again, very wise and needed investments, but it shouldn't continue to be on the back of our ratepayers. And that's the disappointment that I have. And I know as a board, we're always very cognizant of even small rate increases and the impact that it's going to have on our customers. And it's just it's difficult when we have decisions like tonight where we have to do this, but it is gonna be coming out of our ratepayers' pocket. So I just wanted to add that because we didn't really get to mention that today, but for the sake of our public, I want to make sure that they know that we're doing the best that we can, given the new challenges that we're seeing. But again, thank you to staff for working on this. And
Okay, thank you. I know we had one member of the public, but let me make some quick comments. When this first came to us, I was concerned that it came as an approval of a concept and construction without the analysis that we're seeing today. So I appreciate the information we're now getting. I believe it's properly categorized as an interim project. I would suggest it has a lifespan of best 10 years before we have to go to RO. The technology is changing. Wayne Gretzky, a hockey player, once said, you don't play for where the puck is, you play to where the puck is going to go. We don't know where that puck is going to be. So, but we know that the technology that this is being proposed here will not meet the future requirements. Second, it'll be a seasonal plant. Currently, we don't need it because of conservation. Our overall demands, we could meet our current demands even in the summer months with the extraordinary levels of conservation. But even the better times, it'll be needed during the summer months. And so we're putting in a significant cost, even at the 6 MGD level, of $17 million for an interim facility that is seasonal in need. And I would strongly encourage us to look at the other alternatives of coming up with a seasonal water supply. It doesn't require us to deal with the PFAS. And part of that is other parts of the aquifer, as well as looking at the other water supplies we have coming into the system. Until we can get to an RO system, which we can do. But we look at how we're going to deal with the waste products. We currently have some requirements, but the long-term requirements will be disposal of a hazardous waste. And that is incredibly expensive. If we go ahead with this, and I think the majority of the board will be proposing it during the current term, if we look at the ability to repurpose facilities to address hardness in the long term, that will make it a long-term project. And and potential energy sources. It's interesting that the governor was supporting Bloom, which is a natural gas supplier, when many of his supporters are trying to ban natural gas in the state of California. So again, I appreciate the information we've had. I fear that it's an expensive interim fix that really doesn't address the long-term needs of the district, or even the interim needs. It's a quick fix. So, thank you. There was one member of the public that I believe I was told had their hand up. I can't see it on the screen.
Yeah, currently there are two.
Two, all right.
Kelly A. and Ken Nishimura.
Thank you. Kelly A.
Thank you. So on the Hetchatchee storage, I do know of somebody who just went up last week and walked all the way around the lake and took a very careful look at the lake. And I can assure you, based on their reports, that lake is full of water. So I listened to the state board presentation a couple of days ago, and they said that 14% of the state is exceeding these response levels for this thing, for the PF hexus. But they weren't too worried. They said that a lot of these local utilities like ACWD, the water suppliers, they take the response levels very seriously, but it doesn't really, they were kind of left a lot of, they didn't really tell the board. There was no controversy about this. There was no, and they pretend like if they really wanted to take it seriously, fine, but it wasn't really that serious somehow in their minds to put out a response level of 20 ppm, 20 parts per trillion for PF hexus. Right before this issue, they talked for hours and hours about water leakage and regulating pipe losses in the water industry. And the water industry sent many lobbyists there to lobby for looser regulations on water leakage. So, but they had no interest in arguing about PF hexus response levels. So as far as this study goes, very good, careful study. But we're talking about MGD, and as Director Weed was pointing out, we need to look at these annual production volumes too. So let's, cost really comes from the acre feet per year or whatever, the annual production. It does not going to come out of MGD, which is just your peak flow, well, not cost, production volume, the denominator of the cost per acre foot. So there is a full, very good, this study is good because it does break down the operating cost from the capital cost. And you notice that if you do the amortization, the operating cost here is almost equal to the capital cost. Other people, their operating cost is 1.5 times the capital cost on an annual basis. So your operating cost here is comparatively very low. And then the budget process here today, it seems like you're going through things very, rationally, aside from my concern about the annual production volume. With the budget process, it seems careful, it seems legal. And other people are doing this rushed budget process that's full of questionable shortcuts with the staff coming in and screaming about emergencies and demanding immediate approval of large expenditures and designating this kind of a project as a drought emergency, which I think makes no sense, but that's what they're doing. So so it seems like, you're going to go through the proper process and put it in the proper budget and give everybody a chance to budget it properly and so on. One more thing on scaling. This thing at I did the scaling numbers. In most process facilities, process plants, as you double or quadruple your production volume, the cost per unit drops pretty significantly. This thing, the cost per unit only drops by, when you double the production volume, it only drops by like, I don't know, 12% or something, some small number. So you're scaling numbers here. Your cost savings, your cost efficiencies, when you go from 6 to 15 million gallons per day, is very minimal. So you have almost no scaling going on. And I'm a little, I'm not used to that. I'm used to seeing bigger numbers in scaling efficiency, but I don't know. Maybe that's how these things work, but it is interesting. At least I can calculate these things based on the numbers that you present here, whereas some other people that are doing these kind of studies, they don't give you enough numbers to where you can even calculate anything. Thanks.
Thank you. Mr. Nishimura?
Yes, so maybe we'll start with Director Sethy's page 41. I just wanted to make sure I understand the information presented about the energy. There's the table entry is average annual energy demand, but the unit's horsepower. Horsepower is a unit of power, not energy. I assume what was intended to be published there for the 6MGD system is 90 kilowatts, converting horsepower at 746 watts, and that the average annual energy consumption therefore will be 745 megawatt hours. So I just wanted to confirm that. And then to Director Huang's comment about the cost, I guess if you go back up one slide up to slide 40, looking at the table, is it correct to assume that the marginal cost of producing water is at roughly $900,000 to produce 6 million gallons a day for 1 year at 95% duty cycle? If that's the case, I believe $6 million gallons a day at 95% duty cycle or duty factor is 6,385 acre feet, which works out to be about $133 per acre foot. If I add the notional, and I say notional cost of groundwater at $500 an acre foot, which is the groundwater replenishment rate in effect right now, that means that the water that is being produced, the marginal cost of producing an acre foot of water from this facility is $633, which is less than 1/3 the cost, the $2,100 an acre foot that we are paying SFPUC for the quote unquote low PFAS water. So I just wanted to confirm that. And the last question or comment I have, I think goes to Director Gunther's concern. And this was actually part 2 of my previous question, which we didn't get to, which is, are there any technologies to regenerate the ion exchange, right? So in the case of domestic water softening, which is a cation exchange, as I believe the respondent actually alluded to this, is that one would regenerate the in situ with a strong solution of the desired cation, right? So in domestic water softening, you are substituting sodium for calcium and magnesium, and when the ion exchange resin is spent, you would basically soak it in brine, sodium chloride, and regenerate it. Right now, the presentation basically indicates that these quote unquote spent ion exchange is just buried in the ground. And I believe Director Gunther was concerned about, great steaming piles of spent resin. The question is, are there any technologies where one could take the spent resin to a central location and have that resin regenerated, and the accumulated PFAS compounds be treated or contained at this central location, and the resin reused such that we aren't burying huge quantities of ion exchange resin? Thank you.
Mr. Nishimura, I'll let the consultants make the response, but the problem is you have a carbon fluorine bond, and it's a hazardous waste, and you either heat it to 600 degrees Celsius, over 1500 degrees Fahrenheit, or you take it to a hazardous waste dump. It's not a recyclable compound. That's my understanding. Thank you. If there's someone who can.
Good evening. Hi, my name is Ben Egger. I'm a project engineering supervisor. I just wanted to help address the first question there that Mr. Nishimura had regarding power to energy. Marion, I'm not sure if you can skip through to is it 2 slides? 1 slide, there we go. Right, yeah, so good catch. We did provide the energy demand in horsepower. We just felt that that was a little bit more accessible for the general public to consume in horsepower rather than kilowatts. And also that is a unit of power. And so that power rating for the plant is the average power rating over the year. So it's annualized and averaged. As you saw on the process diagram there, there's pumping on the front end for flow regulation, as well as pumping on the back end for pressure regulation. So really over the average annual demand, that's the power consumption need. So yeah, you would have to multiply that out by time, by hours to get the energy demand. So that was a good catch. And then we also provided there under the assumptions the online factor. So there's an online factor of 95%. On top of that, energy demand, and that will bring you out to that annual cost. So hopefully that helps explain the numbers you're seeing there. And then I'll turn it over to Ms. Derby to talk about the second 2 questions, which were the cost per acre foot, confirmation of that, and then a question about IX regeneration.
Thanks. So in terms of the cost per acre foot, the cost per acre foot for the added IX treatment is going to be a sum of the annual O&M cost. That includes maintenance, replacement of the resin, energy. And so that is this $900,000, which you then calculated was $133 per acre foot with a 95% online factor. We then add that to taking this capital cost, assuming a 30-year loan and a 3% interest rate to calculate an annual cost for that. And so we add those together, and that's where we got the $200 to $300 per acre foot. And so that's for the IX treatment, and this would be added on top of the rates for the blending facility. The second question was about whether the IX resin can be regenerated offsite. Right now, there's no cost-effective way to regenerate it offsite. There may be in the future, but the difference between PFAS and hardness is that in order to be able to remove PFAS, which is present at the nanogram per liter, compared to other anions that are present in your solution at milligram per liter, then you have to have a much stronger bond between the resin and the PFAS. And so these resins are designed to be able to strongly bind the PFAS to remove them instead of, just removing all the other salts from your water. But this comes at the consequence that it is hard to regenerate because it is so strongly bound. You can't just remove it with the same sodium chloride solution that you would use to regenerate for hardness removal.
Thank you. All right, well, okay, I think we've completed the public comments. Close those, bring it back to the board for any final comment. And there be none. Thank the staff and the presenters for your presentation. Very informative. Thank you.
Okay,
So,
that does conclude the workshop. Unless there are any other final remarks. So that does conclude the workshop item. That's item 4 on the agenda. Item 5 is general manager's reports, and I have I'll have mercy on everyone. I don't have general manager's reports this evening. So that would take us to item 6, director's comments or agenda item requests.
okay. I make one comment. I've been asked to serve on a subcommittee of the Association of California Water Agencies on PFAS. And so they'll be meeting in September. A manager out of Orange County is taking the lead. There's a fellow, a director from Yorba Linda, who has a PhD in chemical engineering. And Edgar Dimely, who is head of the AWWA Water Quality Committee from the Med. Sarah Palmer, and hopefully we'll be able to bring in our own staff with Laura Heides. So looking forward to those conversations, and it's one of our black swans, I call it, to the water industry, followed by microplastics and then by pharmaceuticals and hormones. So it'll be an interesting journey. Thank you very much. With that, do we have any other items before the board?
Unless there are any other director comments or agenda item requests, then I think that's it.
Oh, thank you. And we are adjourned, and it's 6:45.
Thank you.
Thank you.
All right.
And thank you for the great presentation.
So you guys got through a lot of
I have
material.
something for you here.